We're talking about something every veterinarian deals with, whether you're in a clinic, a barn, a shelter, or a lab: environmental survival and disinfection. Some pathogens die instantly outside the host. Others, like Coxiella burnetii, Clostridium spores, and dermatophytes, seem to survive nuclear winter. By the end of this session, you'll understand which pathogens survive, why they survive, and how to choose the right disinfectant for the right situation. Let's get to it. Environmental survival determines how long a contaminated space stays infectious. It affects how we clean, how long we quarantine, and how we manage zoonotic risk. If you don't understand environmental survival, you can disinfect all day and still not eliminate the pathogen. Pathogens survive based on five major environmental factors. Moisture is the biggest one. Most bacteria love damp environments. Temperature matters. Cool, shaded areas preserve microbes. UV light kills many pathogens, which is why sunlight is such a powerful natural disinfectant. Organic matter protects microbes from disinfectants, and biofilms act like a fortress, shielding bacteria from chemicals and the immune system. Pathogens fall on a survival spectrum. Enveloped viruses are fragile. They die quickly on surfaces. Gram-negative bacteria survive moderately well. Gram-positive bacteria and non-enveloped viruses are tougher. And then you have the tanks: spores, protozoal cysts, and prions. These require specialized disinfection. Pathogens that keep infection control specialists awake at night. Coxiella burnetii survives months in dust. Clostridium spores survive years in soil. Dermatophytes persist in hair and dander. Parvovirus survives for months on surfaces. Salmonella persists in barns and water system. Mycobacteria resist many disinfectants due to their waxy cell walls. Cleaning and disinfection are not the same thing. Cleaning removes organic matter, dirt, feces, hair, biofilms that protect microbes. Disinfection kills microbes. If you skip cleaning, disinfectants can't reach the pathogens. This is the number one reason disinfection fails. The major disinfectant classes used in veterinary medicine. Each one has strengths and weaknesses. Some are great for viruses, but terrible for spores. Some are safe for animals, but inactivated by organic matter. Choosing the right one depends on the pathogen you're targeting. Excellent for parvo and spores, but only at the right concentration and contact time. Accelerated hydrogen peroxide is broad spectrum and works fast. Quats are great for enveloped viruses, but useless against spores. Chlorhexidine is fantastic for skin, but not strong enough for environmental decontamination. Alcohol works quickly, but evaporates too fast for deep disinfection. Disinfectants need time to work. If a product dries before the required contact time, it doesn't kill the pathogen. For spores, you may need 20 to 30 minutes of wet contact. This is one of the most common mistakes in clinics and barns. Matter protects microbes by binding disinfectants and preventing them from reaching the target. Bleach and quats are especially vulnerable. A surface that looks, quote, mostly clean may still be too dirty for disinfectants to work. This is why mechanical cleaning is essential. One of the toughest pathogens in small animal practice. It survives months on surfaces and resists many disinfectants. Bleach or accelerated hydrogen peroxide are the gold standards. Kennels, bowls, and floors must be thoroughly cleaned before disinfection. Phytes survive in shed hair and dander for months. Environmental control requires vacuuming, mechanical removal of debris, and repeated disinfection. This is why ringworm outbreaks in shelters are so difficult to control. Coxiella is one of the most environmentally persistent pathogens we deal with. It survives months in dust and resists many disinfectants. High-level disinfectants or peroxygen compounds are required. Dust control is essential during kidding and lambing. Spores survive for years in soil. They resist heat, drying, and many disinfectants. High concentration bleach or parasitic acid is required for decontamination. The gold standard workflow for effective disinfection. Skipping steps, especially cleaning, dramatically reduces effectiveness. This workflow applies to clinics, barns, shelters, and even home environments. To wrap up, environmental survival varies dramatically across pathogens. Effective disinfection requires understanding the organism, removing organic matter, choosing the right chemical, and ensuring proper contact time. When you get these steps right, you can break transmission cycles and prevent outbreaks. If you found this information useful, please like and subscribe. Thanks for joining, and I'll see you next time.